Disaster at sea is almost always sudden and devastating. The safest means of escape is by lifeboats, but these may never have been used before in an emergency. International regulations state that every crew member must take part in at least one abandoned ship drill every month. These drills are vital to any well-organized emergency plan. They must be practiced in a realistic way as part of the vessel's safety management system. Modern David-launched, totally and partially enclosed lifeboats and their release mechanisms are sophisticated pieces of equipment. Their correct operation and maintenance demand care and skill to ensure the gear is always safe and fully operational. In recent years, a number of accidents have happened during drills because the ship's crew haven't fully understood how to use the equipment. In this program, we focus on one particular area of concern: on-load release mechanisms. This is the result of a lifeboat accident which happened while a drill was being carried out in harbour. The boat had been lowered into the water, released and manoeuvred near the ship. When the drill was over, the boat returned to the vessel and was hooked onto both falls. Hoisting began. About 35 feet above the water and level with the upper deck, the aft hook released without warning. The boat fell into the vertical position. The forward hook ripped out of the hull and the boat plunged into the harbour. It hit the water upside down at about 45 degrees and was immediately swamped. 2 people were killed and 1 seriously injured. 5 people escaped with minor injuries. The investigation and report which followed showed that the aft hook had not been properly closed into the locked position. On-load release systems were introduced with the development of totally and partially enclosed lifeboats. Older lifeboats rely on either traditional hook and eye securing or systems which only permit release when the falls are slack or offload. In rough seas, the difficulty of releasing both hooks simultaneously makes this an extremely hazardous procedure. On-load release gear allows the lifeboat to be released with the load on the hooks when waterborne. A number of on-load release systems have been developed which share a similar method of operation and have common elements. There are hook units, a main control unit with safety pins, a release handle, and hydrostatic locking lever, control push-pull cables, and a hydrostatic diaphragm which is connected to the hydrostatic interlock. On-load release gear for totally and partially enclosed lifeboats is mandatory under revised SOLAS regulations. These stipulate that all hooks must be capable of simultaneous release and that there must be safeguards to prevent accidental or premature release of the lifeboat. Study the manufacturer's instruction manual for the lifeboat gear on your vessel with the help of your ship's safety officer, together with any other reading material and training programs on lifeboat drills. Although on-load release gear is a sophisticated piece of equipment, it is straightforward to operate once you understand how it works. Depending on the design of the equipment, 2 basic methods are used to hold the hook in the locked position. These are cam-type systems and open-topped cone systems. In the cam-type system, the hook is held in the locked position by the overlap between the tail of the hook and the upper portion of a half-moon-shaped cam. A lever on the cam is connected by a push-pull type cable to the main control unit inside the lifeboat. The hook is retained in its locked position by the cam, which in turn is held in place by the push-pull cable. At the main control unit, the cables from each hook are attached to quadrants, which are controlled by the main release handle. Moving the handle causes the cams to rotate into the open position, releasing both hooks simultaneously. The open-topped cone system operates in a slightly different manner. A vertical spindle extends up through the hook housing, with its upper segment conical in shape. The hook tail fits into the top of this cone. Moving a lever inside the boat rotates the spindle of both hooks simultaneously. The open sector aligns with the direction of load, and the hooks are then free to release. Whatever the system, there are several means of preventing accidental or premature release. The main control unit has one, or sometimes two, safety pins that must be removed before the control handle can be operated. The handle is then simply lifted against spring tension and pulled, which releases the two hooks. But it is not possible to release the hooks unless the craft is afloat, due to a further safety measure, the hydrostatic interlock. This guards against premature release. This is built into the bottom of the boat and contains a diaphragm connected via a cable to a locking lever inside the main control unit. As the boat enters the water, the diaphragm lifts under the water pressure, and the cable raises the locking lever clear of the quadrants, allowing the release gear to be operated when required. The locking lever is positioned behind a clear panel in the control unit. This allows the operator to check that the lock is free before moving the release handle, and locked once the boat has been lifted from the water during recovery.
Okay, morning. I'm sure you're all aware what we're going to do this morning. We're going to have a drill. What we're going to do is we're going to lower the lifeboats down to the water level. We're then going to release them, take them for a run around in the harbour there, and we'll bring it back onto the alongside, lift them up. We're also going to test the onload release mechanism as well.
The safety officer should have prepared a plan for the drill, thinking through the aims and objectives of the exercise and identifying areas that need particular attention. Before beginning any drill, careful checks and preparations must be carried out. On-load release gear is safe and reliable, providing it is properly used and meticulously maintained. Lack of maintenance and human error can cause it to fail. All equipment being used must have been maintained in accordance with the required company and legislative requirements. The safety officer visually checks the release gear is correctly set and safe, with all the safety pins in place in the operating unit, and that the hooks are fully locked behind their cam arrangements. You must check, however difficult it is to see, but always with due regard to your own safety. Everyone taking part must wear the correct personal protective and life-saving equipment and have been fully briefed. The boat must then be prepared for launching. On installations where hanging-off pendants and gripes are fitted, ensure these are released and the davit system is safe to operate. Check that the engine and life support system controls are in the start-up position, and ensure that the drain plug is screwed down. Make sure the painter is correctly rigged and the correct length for when the boat is waterborne. After all the safety checks have been carried out, embark crew, checking their seat belts are fastened. Close all hatches and doors securely. The helmsman starts the engine. For davit systems with remote lowering from the lifeboat, the helmsman pulls and maintains a steady tension on the lowering control wire until the boat is in the water. He should never wrap the control wire round his hands. It's important that the boat's descent over the last few meters is uninterrupted. If, for any reason, the helmsman wishes to stop the boat's descent, he should release the manual tension on the lowering control wire. Once the boat is waterborne, check that the hydrostatic interlock releases the interlock lever and frees the release mechanism. The helmsman can then operate the hook release handle. First, the safety pin is removed. Except as a last resort, he must never do this before the boat is afloat. Grasp the release handle firmly and pull it upwards against the spring tension so that the locating pins on the handle clear their slots. Pull the release handle as far aft as it will go and the hooks are free to open. Once the hooks have been released, together with the forward painter, the helmsman puts the engine into gear and steers directly away from the ship. If and only during a real abandoned ship situation, the hydrostatic lever remains in the locked position, either due to failure or the craft has failed to become fully waterborne for whatever reason, it can be overridden. This is achieved by breaking the clear panel and operating the locking lever manually. This action must be considered only as the ultimate and last chance of escape, and must only be taken with the full knowledge that there may be serious damage to the craft and possible serious injuries to the occupants. Overriding the hydrostatic interlock should never be done during a drill. To undertake this procedure, remove the safety pins, break the clear panel on the control unit, and lift the locking lever clear of the quadrants. The locking lever should be held up against its spring in the red zone position whilst the release lever is operated. During an abandoned ship operation, the lifeboat would not normally return to the ship. However, during drills, the lifeboat has to be recovered from the water and returned to the davits. A recent survey has shown that most lifeboat accidents occurred because the release gear was not properly reset. A large proportion of these reported incidents happened while the boat was being lifted from the water to the upper deck. Because on-load release gear allows the hooks to be released even when the falls are under load, it is vitally important that the hooks are correctly reset before recovery of the lifeboat begins. Depending on sea conditions, the hooks should be reset as soon as possible after launch, away from the ship. This must not be left until the lifeboat is in a position to re-engage the fall's end links. While the lifeboat is away from the ship, the hook release handle must be moved forward again, towards the closed position, as far as it will go. The locating pin in the handle is then directly above the slots in the side plates. The bow and stern men must now return each hook by hand to the closed position, making sure that the tail of the hook is behind the cam. Resetting should not require force. The gear is now reset by moving the short resetting levers on the side of each of the two release hooks. Pulling upwards on the levers until they reach the stop position rotates the cams and locks any movement of the hooks. When both hooks are properly reset, the helmsman's release handle will then be free to drop down into its slotted, locked position. Only then can he insert the safety pin. If the pin does not slide in as easily as this, the entire system must be rechecked. Never use force to insert the safety pin. In cam systems, it is critical that the tail of the hook is hard against the flat face of the cam. If either the hook or the cam are not fully swiveled back into their correct positions for locking, a force is created between the hook tail and the cam face, which acts as a lever as the weight of the boat comes onto the falls. This force is initially resisted by the push-pull operating cables and fixing clamps, but lifting the boat out of the water or normal shock jolting during recovery may increase the force to a point where the cable fails and the hook opens without warning. Whatever the system on your boat, the bow and stern men must inspect and pull on the hooks to check that they're securely locked and that the cams are correctly positioned before reporting to the helmsman, hooks are relocked. To simplify the checking of whether the hooks are correctly set, some designs have been fitted with simple indicators. Available as an upgrade, this design has glow-in-the-dark indicators. When they're in line, it is correctly set. If the indicator is in the red zone, the hooks are unsafe. The lifeboat must not be boarded without protection or load taken on the hooks until it has been corrected. This system allows the hooks to be checked in the davits without having to board the lifeboat. Check your system to see if indicators are fitted or whether an upgrade is possible. The lifeboat may now be manoeuvred under the davits, allowing the bow and stern men to engage the end links into the release hook assemblies. Maintaining the correct position is helped by using the painter. The helmsman informs the winch operator that the falls are engaged and that hoisting can begin.
Winchman, hooks are secure, all is clear, and heave away.
Okay.
Once the lifeboat has cleared the water, hoisting should be stopped. The hydrostatic device will automatically lock the hook release handle. A visual check must be made by the helmsman through the clear panel to confirm that this has happened. If not, hoisting must not be resumed. The craft should be immediately returned to the water and the fault found and corrected before any further recovery attempt is made. Once the weight of the boat has been taken on the falls, the bow and stern men should check again that the lower falls links are fully engaged in the hooks, and that the hooks are properly set. This is simpler if indicators are fitted. They can then close the hatches, return to their seats and strap in, and the engine can be switched off. The winch motor is started again, and the lifeboat returned to the davits in the stowed position. Check and know your davit system, especially the safe recovery load permitted. The helmsman or winch operator should always approach the stowed position with care in case the limit switch malfunctions. On-load release gear requires the boat's weight to be maintained on the hooks at all times. This ensures that the hook tail and hook restraining device are always kept in full contact with each other. The occupants should unfasten their seat belts, open the doors and leave the craft, but only when instructed to do so. The final part of the drill is to re-prepare the boat and davit for emergency use. The complete system's boat and davit, control gear and equipment must be returned to their ready-to-go position. An inspection must be made, as required in the operation manual, to ensure the system is in the correct state of readiness. For example, all fuel, oil and water levels should be replenished as necessary. The drain plug removed. Ventilators opened. The hatches and doors firmly closed. After the drill, the safety officer should hold a debriefing session in which every aspect of the exercise is discussed and suggestions for improvement can be made. In this video, we featured one type of release gear. There are various in general use. You should study the release gear fitted to your ship with the help of the ship's safety officer and understand its correct operation and maintenance. Your life may depend on this knowledge. Between drills, a regular schedule of inspection and maintenance must be carried out in accordance with the manufacturer's instruction manuals and as part of the vessel's standard operational procedure and safety management system. Maintenance instructions are detailed in the manufacturer's handbook on board ship and list the work needed by trained and certificated members of the crew in a weekly, monthly or annual format. Careful attention must be given to all working parts of the davits, falls and release gear. These must be kept clean, free from dirt and corrosion, and properly lubricated. Galvanized components, such as the hooks, must never be painted over. For on-load release gear, particular attention should be given to the condition of all cables and clamps and the contact surfaces of the release hooks and their associated cams or cones. Any component showing wear beyond the strictly set tolerances shown in the manuals must be replaced as a matter of urgency. If there is any doubt about their condition, contact the safety officer or the master. To improve safety when carrying out inspection and maintenance procedures, new systems have been designed which enable this to be done with the lifeboat in the stowed position. The HHSP system, shown here, has been approved for this application. It has a lifting capability which allows the load to be transferred from the main hook to the hydraulic hanging-off pendant. Check to see if your own procedures can be improved. In many of the accidents that have occurred, human error has been to blame. Failure to follow the correct operating procedures. Failure to properly reset the release mechanisms. Failure to insert the safety pin fully. Failure to understand the equipment and its operation. Failure to inspect and maintain